Bismillahirrahmanirrahim. Hello everyone, and this is another Seismo structural tutorial. In this tutorial I'm going to show you how to strengthen or retrofit an existing structure using column jacketing. So this is a project I have already completed. Later I will show you this existing structure plan. And so after the earthquake, after the recent earthquake, we evaluated. So the structure should bear at least 2000 kilonewton forces, but the structure capacity is less than 2000. So we intend to strengthen or retrofit the structure using a jacketing method. So there is another method such as adding some shear wall instead of jacketing, because we want to increase the capacity against the shear force. So we can add some shear wall, adding some brasses, using some sort of device such as viscous damper, elastic damper, this sort of device, earthquake resisting system as well. But we provided jacketing. So jacketing is quite economical, and also it's the same from the existing material, and but it requires a lot of work. In some cases you can optimize the economical methods as well. So in this case, just we increase the column cross sections in the two floor, and the top floor is remained as the same. So therefore then we re-evaluate the structure with the retrofitting method, and we got this capacity curve. So you can obviously see it is triples than the first one. Now we want to I want to show you this procedure here in a tutorial. So this is the Seismo structure program, and mostly designed for the earthquake assessment and also earthquake retrofitting. So we go to the modeling, and this modeler is quite popular, and the structure, existing structure, is 3-story. Each story has 3 meters height, and we have the plan of the existing structure, and we know the size of that plan, and I go to bring it that as a DG is a AutoCAD file. So this is called plan, and this is meter. So this is the plan. You can first model your existing structure like this, and then bring it. So I will first model the same structure once more time, and here is using the column is 30 centimeters by 70 centimeters, and I can come to here. From square I can take it 400 by 400 millimeter. The material is as a default we used already with the same, and we're not changing any materials here. And adding the columns to the proper location like this. Now we draw the column, and next I want to draw the infill walls, and I select the center and the middle, and this is a 200 brick from center to center here, from center to center here, and from center to center here, and also from here to here. The modeling is not difficult if you have this AutoCAD plan, and you can model it quite faster. And this one is also here. So now we have this structure and this first floor, but I want to draw the column, the beam as well. So the beam is 400 by 500. So the beam is not do not need to retrofit, just we want to consider the first let's see how it's behave, so then we can imagine, and we can think which part should be retrofitting. So I'm gonna draw the beam. Let me take again from center to center, and this one here from here to here. You can draw entire beam and the program automatically will fix for you. The connectivity will be fixed, and so now the entire beam is modeled, and you can see that 3D, and you can see that 3D model is here. Now I want to draw the slab. The slab is 50 centimeters thickness, so this is 50 centimeters. You can increase in case if your project is different. So I'm going to select this one, this one, this one. So here is the opening. I'm going to keep it as open. Now from here I want to copy this to floor 2, and again I can go to here, select to floor 3. So the 3 floor is same, and I'm going to third floor here, and I want to take the slab again and close this area. Now the modeling is completed because it's very quite simple structure. I'm going to 3D back here, and this is the 3D, just showing last floor and second floor. So I'm going to back to the here to the first created the project and call save the model and call model existing building. So this is the existing building models, just the model, and it bring. Now here is the case. So I have about 2000. So when you have that existing structure with the available earthquake data, then you will calculate the total mass of the structure using the equivalent lateral force method earthquake design, and you take the shear force. So the total shear force of structure is 2000 kilonewton. So that 2000 kilonewton will distribute to the entire structure. So I'm give the 2000 to structure, and the program automatically will distribute to the structure like this. So what we're gonna do is, based on the giving determined earthquakes load, so we have 2000 kilonewton, and we want to evaluate the structure capacities. So the model is already, because everything is modeled there, and the program will create connectivity between infill walls, beams, columns, everything, and we assume the material is a default. If you go there and you can see this material that we use, but for your own project you can change it. Changes are not difficult. You can come to here steel, and you can use any steel you want. So I use steel MPB. You can use any steel you want. Now what we're gonna do is we're gonna processor, and we conduct the analysis. It's called before running. You want to send. I'm gonna send. It's called existing building, and I'm gonna save it. Existing building called tutorial, and I'm gonna save it. So the analysis started, and you can see the analysis. The program based on the defined slabs, everything's slabs, elements, all elements, and it calculate the structure response. So I'm going to call post-processing, and you can first come here and you can see the eigenvalue result, and you can get the time period, and then you can go to here is the curve which we already saw it. So it's 1900 is almost, but less than 2000. So I can select here, select all, and I'm going to copy this selection, and I'm going to add in this area, and call paste. So when I paste, so the curve is changed, and it takes less than 2000 just giving a new one. So I go back. So now we already made one. So the next thing is I can exactly go to create a new one. I can save it this one, and I'm going to go to pre-processing, and I wanna take it a new file. So the new file, we go back to the modeling. We can bring that open existing project as well, which is already we have modeled, but it is better to create a new one that will be quite fast. Now the same things, and I'm gonna create a project with these properties. So the same, I will bring the existing plan meters, and you can see this is 400 by 400 millimeter column. So what we're gonna do is I wanna use some sort of jacketing. Instead of 400, let me make it 600 by 600. So I'm gonna column, and from the column I can comes to the geometry first, and I select 400 by 400. Now I can go to jacketing. In the jacketing, you can see here it's called no jacketing is exist now. In this type, no jacketing. So but we're gonna using full jacket, means the entire column should have like this. You can see here, and this is jacketing. You can create jacketing for the foundation for the column. So I want to create a jacketing that is the existing column, and it is 600 by 600. So the 200 is extend. So now it's okay. The jacketing type is, you can change the rebars as you wish, but what we're gonna do is I want to just keep it as I want to keep it like this as a sample, as a default for the project simplicity. So now the same method I can use there, and the existing column is drawn with jacketing. So I can go back to draw all the available columns. So these two columns actually it's not it's just very short, and the span is very short, so we do not need to add this one as well. So but I can go to back to here, and I just call no jacketing is getting for this area. So no need, because as much as we reduce the work or the time of construction, so we will think about that economical issue. Now we go back to the the same infill panels. So the infill panels is actually we not has any effect on the earthquake resisting, so we do not increase the thickness as well, so just keep it as it is. And again we want to and this is the so we have finished now here. Let me draw the beams. So the beam is using geometry 400 by 500. So this one, and the same default properties, and we are not going to retrofit or retrofit this beam, because this beam is so we not have plan to retrofit or restrain the beam. So we're gonna keep it as the existing size as 300 by 400 like this, and we're gonna draw again, and so now the column is modeled, and just one is left here. The last one, I want to add slab. So the slab is also the same. We're not going to extend it the size or anything else, and just keep as a default with giving load. Added this one, but except this one. So next I gonna go to here, and here copy the first floor to the second floor. I'm gonna OK, and I can go to the model, and you can see the first both two stories in the same size is modeled. Now I'm gonna go to the second floor, is also same. Third floor, the third floor should be as existing, so we're not going to change the size. So we're taking this one is the same. You can see 400 by 400. You can model like this, and the same infill walls, and also the same beams, and also the slab should be here fill. Now what we're gonna do is we're gonna go to save the model, and we save the model, and we give again the 2000 kilonewtons to see how it works. So here is the retrofitting or stringing structure. So we just use some jacketing method, increase the thickness or the size of the column like this, just 2 floor. And in case sometimes that 1 floor is enough, you can increase 1 or 2 based on your project and your requirement. So now we go to the processor and we run the analysis again and see it's called before running. I'm gonna save it. So I'm gonna save it, called strengthening. You can use renovation building. And you can save it, and the program will run. Start run. Here is the performance criteria. Is called crash reached in the specific loading. So we can go back to the post processing and see the response, and we can see the deformation. In previous one, the deformation in this area was, you can see the column is quite strong, the beam is the deformation in this beam column joint is quite larger. But we cannot verify these things, the crash or any sort of major cracks in this method, in this deformation. But we can go to see the global response parameters and also the performance criteria checks. This is very important parts. But before that, let me go to show the target displacement. So now target displacement is increased significantly, and it's reached to 4,500. If I go select all and copy, and I go to back to the here, and I paste it here, I'm gonna paste, and you can see the curve is changed. So now this is the existing structure and retrofitting. So but we can also evaluate the performance here, and you can, it's the yellow part, which is the first yellow part, it's here, is greater than 2000. So that means the structure is now capable to bear 2000 earthquake, 2000 kilonewton shear force that caused from the earthquake. Now here is other parameters, and is some area which is some partial structure is collapsed, and I'm going to call the performance criteria, and I can select you can select when crash or all. So you can see here the materials and also the crash yield fracture. So I'm called, let's see the yield. So in this step, a number of put 0 is none of them is reached. So I'm gonna going to this area, and you can see some element is reached. So this is section beam is, this beam is reached to yield. You also can see in this loading pass, we have 50 steps, and each steps has like if you go here in the we have in the target displacement, we have 80 centimeters, so that 80 centimeters divided by 50 steps, 51 steps. So each step has different displacement, and you can get this. And so now here is the yield. So the yield is most of the beam is, some of them is reached. If you go to this one, yeah, some of them is reached. And also in the end of the loading, and you can see here we have a loss of reached, which means yield. We're gonna the crash is very important, and so this beam is also crashed. So and when we see this is the beam is crashed, that means significant damages happen to the beam. So we should provide some sort of renovation for the beam as well, and those beam, and you can go that find that beam, and when you find that beam, you can increase the stiffness and the strength of that beam. We also can see the fracture, and you can see fracture is not reached yet in none of them. So there is no fracture in the structure, but we also can see which only the criteria reached. So you can go there, so not one and crashed, and you can see only criteria. So this amount of beam is already reached to the crash. So you can see columns. So this is a column, this is beam. So here, and you also can go to the crash confinement, which is the confinement, which is the inside concrete with the stress, so that area is not. So the unconfinement is crashed, which means it is partially this area. If I go back to here, show you the concrete clear cover is actually crashed, but the structure has capacity to resist the load. So this is finished, and we have made this one, and by adding jacket to the structure, and finally we got this capacity curve, which is capable to resist under 200,000 kilonewton shear force, but the existing structure was not capable. So this is the end of the tutorial. If you have any question, please put in the comment, and I will find time to answer you. And the next tutorial will be adding some shear wall, and also adding some sort of brasses. See you next time.